Okay, this is multiplication. So let's say we have 3 times 6. Okay, and what do we mean by that? Well, basically that means 6 plus 6 plus 6, right? So multiplication is repeated addition. All right. And there's the two models that we've talked about with the both addition and subtraction, and they work really nicely with multiplication as well. So let's see. So the set model, and the set model, remember, is basically just numbers of things that you can make sets out of. So if I have 3 sets of I should have done smaller numbers. So I have 3 sets of stars of size 6. Okay. And just a couple of things are, let me just mention, so the numbers in the multiplication are called the products, the factors, the answer, the result is the product. Okay, and that actually, oftentimes I've said, it's like, well, add-ins, I don't use add-ins all the time. Factors are very important in mathematics. We're going to see this a lot when we get to the number theory part of this, where we talk about prime numbers and so forth, and factors are going to be huge with that. Okay, I did set model. I didn't do measurement model. Let's look at that. Measurement model. Again, this typically means that what we're doing is measure, well, not typically, it means we're measuring some kind of quantity. So height, length, volume, weight, mass, things like that. We typically do a number line with this. So 3 hops of size 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 5, 6 is 18, right? So 6, 6, 6. Okay. So we've got both of those. All right. Good. All right, so let's talk about a few properties of these things. I'm going to leave the set model up because I'm going to talk about that in just a second. So let me leave this up. It took a while to write down. So the first one we saw before with addition, I've got 3 times 6 is 6 times 3. Remember, 3 plus 6 is the same as 6 plus 3. And that's the commutative. And that's because basically what we can do is I can take, and this is why I left this up. So what does this tell me? This is 3 sets of size 6. This tells me I have 6 sets of size 3. And if I just break these guys into halves, and this doesn't always work, sometimes you have to rearrange things, but you can quite easily see that this holds using the set model, which is quite nice. The other thing that you can do is there's the array model. I did that in a different video, so I would take a look at that, which is quite helpful as well. Okay, other properties. We have 6 times 1 is 6. That's the multiplicative identity. Again, remember, identity means that nothing changes. Like whatever I put in, I get out. And so what do I multiply by that doesn't change it? Well, I multiply by 1. So remember, additive identity was adding 0, because adding 0 doesn't change anything. This means multiplying by 1. Okay. There's also an, let's see if I did 6 times 2, 3 times 6 times 2. This is associative. This was the same for addition. So addition, 3 plus 6 plus 2, and 3 plus 6 plus 2 is the same. So it's the same thing with multiplication. And so the combination of those two leads to the any order property for multiplication as well. So meaning, and I'll do an example a little bit later, if I give you a handful of numbers, you can multiply it any order that you want to, which is often fairly helpful. Okay, now, there's one, so that looks a lot like addition. This is the one property that contains both addition and multiplication in it, and it's called the distributive property. And this is something like 2 plus 3 times 4 is 2 times 4 plus 3 times 4. Okay. So let me show you, there's a number of ways that you can actually show this. I'm going to do a little grid here. Let's see, I'm going to do that size 4, 1, 2, 2, 3, 4. And let me do, I'm going to shade this in green. Okay. So actually, why don't I shade this guy in red? 2 times 4 is right there. 2's on that side and 4 on that time. 3 on this side, 4 on that side is right here. Right. So looking at it as the pieces, 2 times 4 and 3 times 4. Right. Looking at it on this side is like 5, right? Length 5. 2 plus 3 is 5. Okay, so this shows if I have 2 plus 3 times 4, I can just break it up into 2 times 4 and 3 times 4. Right? And again, this works for all sort of integers, whole numbers that we're talking about now, and we've got that. And I think that's what I wanted to cover with this video.